Yeah, so a couple more lightning talks, and I'm just going to walk through one of the new transformation tools that have been added to FME 2013, which is the Geometryvalidator. It combines some of the functionality that quite a few of the other transformers have in FME, the OGC Geometryvalidator, the self-intersector, and some of the other 3D validation tools that we have. Part of the motivation for this work was to consolidate a whole bunch of transformers. That's always a nice thing, so that there's fewer transformers in your workspaces. But another one was that some of the existing validation tools that we had in FME actually always changed your data. So like a self-intersector, when you wanted to check for geometries that had self-intersection, it actually cleaned up the self-intersection at the same time. And there were some, I guess there still are, some users who really just want to do a QA on the data and they don't want the data to change. And so that was part of the motivation here, was to sort of change some of those tests so that you could choose whether you just tested for valid geometries or actually repaired them as well. So that's some of the work that we do. And then, of course, what we needed to do is to report out a little better what was wrong with the geometries that you might be validating. So the geometry, did you steal my little pointy device there?
I didn't steal it.
So the Geometryvalidator has an option at the bottom there. Do you want to repair your geometry, or do you want to just test to validate it? If you just choose to validate the geometry, there's 3 output ports, and you'll only get data coming out of 2 of those ports, which is passed. Yeah, that was a good piece of geometry you had there. Failed, and no, it failed the detection. If you choose to repair the geometry, then you potentially get output from all 3 ports on this transformer. The passed, yeah, was a good geometry. It failed to repair, so we don't promise to be able to repair every kind of geometry. And if it was repaired, it comes out the fully repaired option. And then we have some various levels of issue reporting in here to tell you where some of these errors potentially occurred. So this is kind of a classic case of some self-intersection geometries, 2 intersections here and here. If you're asked to repair or validate this, you'll get a few attributes thrown up onto the feature which describes where the first of the bad occurrences of the geometry occurred, and the kind of error that FME detected. We also use a thing called geometry traits, which are like attributes thrown onto individual geometries, and that's where all the gory details of the detailed errors of the failed geometry are. And so in this case here, we've picked out on one of the geometries that we fixed that it's a self-intersection, the location X and Y is this, and so on. One of the interesting things we did discover here is, as we're testing these geometry validation tools, is that different databases behave in very different ways in the way they see a bad geometry. And of course, some databases do clean up the data. So an example would be this case here. I forget which way around it is. Iris, who is here at the back, has done a lot of the testing on this tool for us. And so what we found is that, say, in Oracle, if you had a self-intersecting area like this, once you repair it, Oracle likes this area to be not a donut, but that these areas are actually part of the outside world, and it's just an area. Whereas Esri, if you threw that into an Esri product, these would become holes within a donut kind of polygon. So different databases actually view different quirks of the geometry in quite different ways. So far we've added 12 tests to the Geometryvalidator, and we're going to be adding more. We're testing for things like not a valid number for a geometry, null geometries on different geometry parts in the geometry that you're throwing at, duplicate points, self-intersections, 3D surfaces missing vertex normals. If you ever miss any of those, you'll know that you can catch them. And then the OGC simple and valid tests are in there. So just having a look at some of the tests that FME can run for you and how those are reported back to you. We can have a look at a simple workspace here. And we're just reading in some parcel information, filtering it by geometry, trying to build some areas, and then throwing that through the geometry validator. And in this case, we're asking it to repair the geometry. So we could just give that a quick run and see what the results look like. It'll pop up into the new data inspector. We've got a couple of here geometries that we did repair. If we zoom in on one of those, we can see that it's got some sort of a spike down here, and if I click on that, we get all the details here on that feature telling us that it was a self-intersection. So those attributes are the summary of what went wrong on that geometry, and down here a little bit, if we poke around a little bit more, we can see that there are some geometry traits here that give us a little bit more detail as to what would be wrong with that geometry. And if there were multiple errors on that geometry, you'd get multiple geometry traits in here. Let's have another look at a slightly different example. And what we can use here, it's kind of difficult sometimes to look at those geometry traits if you're not using the data inspector tool. So we have a geometry property extractor tool in FME where you can choose to move traits up to attributes in FME. So if you do want to have a look at the detailed reporting from the geometry validator, you can do that as well. It's sometimes important to sequence the tests that you're running in your geometry validation, so you can pick on tests and move them up or down. If I can, actually, there we go. So we can make a check for null geometry parts before we check for invalid individual coordinate values and so on. So you can choose to move those up or down. You can choose which tests you do, and we are sort of grouping those together. So if you just want to do an OGC test, you can choose whether you're going to do those, or you can choose to do basic geometry, integrity, and so on. And I think down the road what we're looking to do is actually looking for custom clusters of tests that might pertain to a specific database. So down here in a set of issues to detect, you might have for Oracle or for Esri geodatabase and so on. And we would choose which specific tests Esri cares about, and perhaps which specific parameters on those individual tests we need to set to make sure that the geometry that you're working with is valid for Esri data sets. And within that geometry validator, we've also added tests for some of the 3D geometries that we're working with. So in this example here, there's a bit of a building here that's got some inverted faces as an example. And once you've run it through the repair, it'll fix up those faces and that building will appear here correctly. So we are doing more and more around the testing of 3D geometries as well as conventional 2D and 2.5D geometries.